You write a playbook that works perfectly on your laptop. You push it to CI, and it fails. Different Ansible core version. A collection pinned to an older release. A Python package that only existed in your local bin. This has a name, implicit environment dependency, and it has a solution. In this video, you will learn what execution environments are and why they were introduced. How to build them with ansible-builder using Schema version 3. 7 rules that separate a production-ready EE from one that causes problems in 3 months. And how to automate builds with Git and CI. An execution environment is a container image that packages everything a playbook needs to run. The base image provides the operating system and Python runtime. On top of that, a pinned version of Ansible core, the Ansible collections your playbooks use, Python packages, and system RPM dependencies. The same image runs on a developer's laptop, in CI, and in the automation controller. No more surprises between environments. The tool responsible for building EEs is ansible-builder, open source, available without a Red Hat subscription. It reads a file called execution-environment.yml and produces a container image. Once you have the definition file, building is a single command. No manual steps, no implicit state. This is a complete execution environment.yml using Schema version 3, introduced with Ansible-builder 3x. Each section has a clear responsibility. The base image, the Ansible core version pinned via pip, the Ansible runner version, the Ansible collections with explicit versions, Python packages, and system RPM packages. 7 lines of YAML replaces hours of environment documentation. The definition file must start with version 3. If you omit this line and use version 3 schema keys like images:, the build fails immediately with a cryptic definition error. If you use old version 1 syntax, it may succeed but emit deprecation warnings and produce an image without version 3 features. Declaring version 3 explicitly also documents which Ansible-builder version is required. Red Hat ships 2 base image categories. EE minimal includes only Ansible core and Ansible runner, the recommended starting point. AE supported ships dozens of pre-installed collections and is designed to be used as is, not as a base for customization. Adding collections on top of EE supported creates version conflicts that are hard to debug. Rule 3. Never use the latest tag. It breaks reproducibility and has been removed from Red Hat images since AAP 2.7. Always use an explicit version like EE minimal, rel 9:2.16, or a SHA digest for maximum immutability. The temptation to build a universal EE that includes every collection an organization needs is understandable. In practice, collections from different domains frequently have conflicting Python dependencies. Cisco networking collections and cloud collections have incompatible requirements. The right approach: 1 EE per automation domain, Linux, network, Windows, cloud. Each image is smaller, faster to pull, and easier to reason about. Every dependency must have an exact version. Galaxy, PyPI, and system package repositories release new versions continuously. Without explicit pins, 2 builds of the same definition file at different times can produce functionally different images. An additional benefit: when you update a dependency, the change appears as a Git diff. It becomes visible, reviewable, and traceable in the repository history. The EE minimal image uses microdnf as its package manager, not DNF. If your definition includes system dependencies and you omit the package manager path option, the build fails with a cryptic error at the run pkgmgr step. Rule 7. The definition file, along with requirements files, must live in a Git repository. Builds should be triggered automatically by Git events, not run manually. This applies the same configuration as code benefits to the EE lifecycle: auditability, peer review through pull requests, and rollback to a known state. To recap, 7 rules that transform execution environments from a fragile artifact into a trustworthy one. Declare everything explicitly: the schema version, the base image, the collection versions, the Python packages, the package manager path. Combine with Git versioning and automated builds, and a well-defined EE becomes something that can be inspected, audited, rebuilt, and promoted across environments with confidence. If this was useful, leave a like and subscribe. Thanks for watching.